What is up, everybody? Hugo Bown-Anderson here. Thank you so much for coming to this talk, and thank you to Comet for putting on this incredible conference. I've spoken at this conference a few years ago and had a wonderful time, and I'm so humbled to be invited back and want to say thank you for putting on such a great conference. I'm here to talk about evaluation-driven development, essentially how to build reliable AI systems using a software development lifecycle. Where you build, deploy, monitor, and evaluate rapidly. So a bit about me. My name's Hugo Bown-Anderson. My background's in bio, mathematics, physics, working in basic research at Max Planck Institute, Yale University, among other places. Then around, I'm showing my age now, but 10 to 15 years ago, I started working in industry, data science and machine learning, data camp, SciPy stack, PyData stuff, and embedding in those communities. Then I moved into developer relations education, working on really what it looks like to productionize all the things we'd been building previously and more robustly using an ML ops stack, distributed computing, these types of things. About a year ago, I went freelance and I've been building the whole time, building AI systems, helping other people build AI systems and teaching people to build AI systems. And I'm really fortunate to have just wrapped up running a month-long course with nearly 100 builders from some of the most wonderful places, doing incredible work, and it's been really inspiring. So I'm excited now to bring a lot of the learnings from that to you as well. So what we're going to talk about today is why you need evaluation and how you can get it even without users initially. What eval-driven development actually looks like, how to build the evaluation loop step by step, and then observability and instrumentation in development and production in dev and prod. So let's jump in to talk about why you need evaluation. I talk with a lot of people and help a lot of people ship AI systems and products. And one of the most common stories I've seen over the past couple of years is, I have documentation. Let's build a retrieval system, some RAG, some infinite RAG, whatever it may be, agentic RAG, maybe add an agent. Then one of several things will happen. And some of the two most common are, we shipped an MVP. Does it work? Another one is, oh wait, I've been using GPT-4o Mini, Gemini 2.5 just dropped. Let's switch it. I wonder if it'll work better. And then after both these questions, then we discover, how do I even test it? And what are we even trying to do with it? And I said these are like two of several questions, like when new RAG techniques come out or new vector databases, it's like, or new chunking strategies, infinite RAG. The question is, can I switch it out and get more performance? And the real answer to that is you need some sort of evaluation framework, right? So that's what I'm here to talk about today. And so when people tell me this, I say to them, what is the goal of the product? Who's your ideal user? In what scenarios will they use it? And most of the time, people haven't thought about this yet. They got very excited with the technology, which is reasonable. And they're like, let's build this agentic RAG system over, all of our Confluence, and spreadsheets and API, blah, 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 right? And that excitement is absolutely understandable. And I love it. But remember, we're here to solve user pain points in a lot of ways. So if you can initially at least spec out something, a product page, a one-page spec of what is the goal, who will be the user? In what scenarios will they use it? If you answer these, you can then start a data flywheel and call what I call a minimum viable evaluation loop before you even launch. So with any MVP, minimal viable product, you can launch a minimum viable evaluation loop. And I'm not talking about like LLM as judges in your production loop and that type of stuff initially. All I'm talking about is a basic reproducible script which captures a few things that you're interested in, that you can run different versions of your app and AI system against. So what does this eval-driven development look like? And I'm going to talk about it before launch, but everything I talk about applies to how you then iterate time and time again. So what you can do is you can build an MVP and generate synthetic user queries. And this is what I'm going to show you how to do. Pardon me. And then you can, So what you can do is, before you even launch, you can build an MVP and generate synthetic user queries. And that's one of the things I'm going to show you how to do today. Then you can label the responses by hand. Was this response pass or fail? Give a reason why, okay? That's labeled data. You can use this labeled data to build a basic evaluation harness. And that term, like LLM as judge, seems a bit, people are like, whoa, that's serious. All an evaluation harness is a script which automates evaluation where you check for certain things that you want and see what performance is like, and we'll see what that looks like. So essentially you have a test set and an LLM that is a judge, and you've got a variety of other mechanisms you can use as well. Then you use this MVE, the basic eval harness, to evaluate and improve your MVP, and you get virtuous cycle there. Now, for those who've been working in, this is one of the jokes, right? For those who've been building products with machine learning for years, this is what we've been doing. It's just slightly in disguise, okay? So evaluation-driven development isn't new. We've been doing it for years in ML. You'll build an MVP in machine learning and collect data. You'll have labeled responses that you have by hand or some other mechanism, ideally by hand, of course, and then you use labeled data to build a basic eval system, like a test set. Well, a test set, right? And then you'll use the MVE to evaluate and improve your MVP. And to be clear, test sets, this isn't, just relegated to the world of the common task framework and Kaggle. If you think about how Facebook, Meta, if you think about how Facebook or Meta bootstrap their computer vision facial recognition in photos algorithm, they got all of us to hand label some things in the early days, and then they got us to verify their hand labels, right? So that was their test set. So this stuff definitively happens in some of the biggest production grade algorithms known to our civilization. So then what's different and what's familiar about evaluating LLM apps? So in a machine learning workflow, you collect real world examples. In an LLM app workflow, you can start by synthesizing realistic queries from personas pre-launch, okay? But then you do get real world samples as you move on, and you can actually get users to label them, as we'll see. You label outputs by hand in the ML workflow. In the LLM powered workflow, you label outputs by hand as well. Then you train the model on labeled data in the ML workflow. In the LLM workflow, you'll prompt the model and tune the prompt and system setup. In the ML workflow, you'll evaluate on held out test set. In the LLM workflow, you evaluate using your MVE, your eval harness test set, plus some sort of auto eval, which we'll get to. Then you iterate based on performance in both cases, okay? So the point is that both workflows are grounded in test sets, iteration, and failure analysis. So how do we actually build this evaluation loop step by step? To start, you want to build your MVP, whatever that may be, right? And then you want to do some sort of evaluation, maybe first by vibes, where you're just looking at it and seeing what's up. And maybe you see certain types of questions, for example, just aren't answered correctly, and you iterate on the prompt there, okay? But then maybe you do some error analysis, which we're about to get to, and build a harness, and then that will allow you to iterate on the MVP. But what are you actually evaluating here pre-launch? Well, first, you can define your persona. Who's your user? You can think about the scenario, how they use your app. You can create realistic test data with synthetic data, and you use that to bootstrap your synthetic data flywheel. So moving from vibe-based to more robust evaluation, I just want to tell you a bit about why structure matters. So when you eval by vibes, it's cool. And early on, it's very useful, but it's subjective. It seems better, whereas an eval harness provides objective, measurable metrics. Vibes are inconsistent, difficult to repeat, whereas an eval harness is a repeatable, structured evaluation process. Vibes, you don't get a historical baseline. It's unclear if the improvements matter, whereas an eval harness, you can clearly track improvements and regressions over time. Vibes, it's hard to communicate results clearly and reliably, whereas with an eval harness, something programmatic, you can clearly document results and it's easier to share and analyze. Now, vibes are impossible to maintain consistency across team members, including yourself on Monday after you've done something on Friday, whereas with an eval harness, you get standardized and reproducible evaluation metrics and results across team members. So wait, what are we even talking about evaluating? Okay, so a lot of people would say, accuracy of, or precision or recall, something from the confusion matrix of, what sources the RAG system, information system, retrieves, accuracy of final response, these types of things. Now, I agree, we need to think about these things, but that's not necessarily the most important thing. We want to track cost. We want to track latency, right? Time and money, people. We want to track user and business metrics. Does it actually impact the final thing we want to move the needle on? So one example that we actually covered in my course recently, we built an outreach agent to people with respect to jobs based on LinkedIn profiles, right? And you can look at, did I extract the correct information was the structured output correct? Did the email look like the emails we sent out previously? Get a domain expert, subject matter expert involved. Fantastic. But the real question you want to tie all this to is, does it result in better candidates being hired more quickly, right? So you do want to look at micro evaluations, such as accuracy of different parts of your pipeline, but you want to make sure you tie these to your top level business metrics, right? So in an eval harness, you'll be measuring these types of things, and then you'll have some sort of quote unquote ground truth. So you'll have a bunch of AI system responses, inputs and queries and responses, which you've labeled as pass, fail with reasons, and you'll compare new AI system responses against them. So this is your test set, right? According to all of these metrics. And you can do an LLM as a judge, and we'll see how that works. But you can also do a lot of stuff we've been doing for years, like structured outputs and string and fuzzy matching and these types of things. So the example I'll be going through to ground this is a RAG system over workshop transcripts. And this is something we built in the course that I just taught. And in fact, I built a workshop transcript agent where all of us can query the workshop and interact with it using an AI system. And a participant in the course turned it into a Discord bot where you can give it +1 and -1, pass and fail, and give a reason, and logs all of that to build the eval harness. So it's so much fun building at the moment is all I want to say. So what I'm going to take you through is we've built a simple RAG system. Okay, using workshop transcripts. Then we're going to define personas and realistic scenarios to simulate user needs. We're going to generate synthetic questions to simulate user needs. Then we're going to use LLMs such as GPT-4 and Gemini to generate responses. We're going to label outputs manually to define correctness and failure modes. Then we're going to build an evaluation harness using those labels. And it will be manual and LLM as a judge. Then we're going to compare outputs from multiple models such as GPT-4 and Gemini, and use failure analysis to drive iteration and improvement, okay? So the main takeaway is you want to build a minimum viable evaluation loop. So this is a fast, transparent loop for testing and improving LLM apps. And you can do this even before you have users, and of course afterwards. So firstly, we define some personas, okay? So the personas I decided for this particular app were a data scientist, and I have a description there. So they have strong analytical skills, intermediate ML knowledge, who wants to incorporate LLMs into their data analysis workflows, and some goals, and then their technical level. And this will help me generate synthetic queries on their behalf, right? Another persona is an ML engineer with strong programming skills and production experience who's building LLM-based systems for deployment in real applications. Once again, some goals. Their technical skill level is advanced, right? So those are the personas. Now, what scenarios will they be using this application in, this AI system? So you could imagine a student in the second cohort, which is the one that just closed, trying to evaluate their own implementations and understand what makes a good response. And I've got some context there. So that's them. Then what type of questions may they want to ask? There are general questions. So questions about fundamental concepts, terminology, principles of LLM-powered applications. There are technical questions. So these are about implementing specific components or techniques. Then there are factual questions, such as questions about specific content presented in the workshops, okay? So once we've done that, we can feed those users and personas into an LLM to generate, let's say, 20 synthetic queries, okay? And that's exactly what I did. So what we want to do then is run the queries through the system and start hand labeling responses. And what you see here, there's many places you can do this. Something I love to do is just to do it in spreadsheets or something along those lines, right? And then you can do the pivot tables we'll talk about soon. I know they're not, the spreadsheets aren't the shiny objects that, we're all playing around with at the moment, but they can be so valuable in this process. The other way I like to do it is to essentially software compose or vibe code some custom JSON viewers. So the user queries, the synthetic queries and the responses are all I've stored them in JSON. And what I can do I'll use continue or cursor in agent mode with, Gemini 2.5 or Sonnet 3.7 and get it to help me build something like this quite quickly, which allows me to look at my data and then give me a pass or fail. And I very much encourage you all to incorporate these types of ephemeral software development processes we've called it vibe coding. Me and people I know prefer to call it software composition, because I think that speaks more to what we're doing. All that aside, you just need something which allows you to look at your data and annotate it quickly, okay? So that's what we've done here. And you can see, I asked the question, what are the first principles for building LLM applications mentioned in workshop 1? So focusing on workflows, iteration, hands-on development. Building production-grade systems that scale beyond proof of concept. Not being a deep dive, okay, great. Prioritizing logging, monitoring, and tracing in LLM applications. Okay, great. So what we can do then is give it a pass and fail and state a reason and so on. And you see here, the question is, who were the instructors for the first workshop? The instructors for the first workshop were Hugo Bown-Anderson and Stefan Krawczyk. Now, this is a really nice example because when we would want to build an evaluation harness for this, maybe we don't care about an LLM as judge because all we want to know is that it said Hugo and Stefan. So we want to do some like string matching or something along those lines, or fuzzy matching, right? Regardless, we run queries through the system and hand label responses. People say to me, how many should I hand label? And I say, start with 20. I think that's a nice number. I do think if you start with 20, you'll start to see like a bunch of wild stuff happening in your system and you'll want to do more. The other thing people say when I say hand label responses, they say, oh, can't we get an LLM to do that? Or can't we get an agent to do that? And I say, whoa, 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 whoa. I say, whoa, because how do you know that that LLM or agent is going to be aligned with what you want the software to do? So if you trust the system to do that, I'd encourage you to. But what I'd encourage you more to do is hand label yourself, do 20, then get an LLM to do the same and have a look at the differences. And when you do that, nearly all the time, you'll be like, whoa, I'm glad I hand labeled. So now we have these logs. We want to turn them into fixes. How do we do that? So if we have them in a spreadsheet, for example, we add columns as we've just done in the JSON viewer. So we can take that and take that JSON, put it in a spreadsheet. We want to accept or reject a response. We want to look at the reason for accepting and rejecting and state that. Then we want to classify the failure mode. Do we think it was a hallucination? Do we think it was a retrieval issue? Was it formatting, structured output issue? Then we do a pivot table, right? One of the greatest technologies known to us. And what we can then do is have our failure modes ranked by frequency. And so, for example, you may think that the retrieval step was the biggest problem in your pipeline. But when you do your failure modes ranked by frequency, you may see the OCR, optical character recognition of ingesting your PDFs, was the thing that introduced the most failures. So then you can focus on that. All I'm suggesting here is a process and a system that allows you to focus on fixing the large failure modes, okay? And so once you have these ranked by frequency, you've got actionable fixes. So, we could rank order, how easiest to hardest and what I'd start with, definitely start with prompt engineering. Then if you've got information retrieval, start playing around with chunking, RAG, vector database, this type of stuff. At the very end, perhaps fine tuning, but there are lots of different types of fixes you can do in the meantime. So I just wanted to show you what this looks like, okay? So if we have an input summarized doc and the output is dogs are cool and we know that it should be a company report summary, we'd give that a fail. And we'd say it's a hallucination in the failure mode. Similarly, if it's get CEO name and the output is John Doe, but we know it's Jane Smith, fail. Failure mode retrieval error. Summarize docs, quarterly earnings, except no need to put a failure mode. Summarize doc as input, output. The report discusses sales, and yet the ground truth is the report discusses sales, revenue breakdown, and customer trends. We'd give it a fail and say incomplete response. Now, one thing I want you all to avoid, it's very natural to be like, oh, this is kind of okay, so why don't we have a scale of 1 to 5 and give it a 3 instead of a 1 and instead of a 5? Do not do that. Do that later on if you want, but at the very start to build your first minimum viable evaluation loop, do not do that because it's not clear what to do with that response. A 3 doesn't tell you anything. A fail tells you need to fix something. A pass tells you you're chill, okay? So, this is what it looks like. This is what labeling examples looks like. I'm laughing because it's so unshiny, but it's one of the highest leverage things you can do, okay? And then once we do a pivot table, what we actually see is what's breaking most often, right? So list the failure modes and rank order them and look at the percentage of times they occur in this failure mode column. Hallucinations, 30%. Retrieval error, 25%, incomplete response, 20%, format issue, 15%, other, 10%. And to be honest, when you eyeball your data, it may be the format issues ones which are more obvious because they catch the eye, right? And you might be like, oh, I want to fix those first. But they only account for 15% of the failures. So if you focus on retrieval and hallucination, you could get 55% lift, right? As opposed to only 15 if you focus on flow. Look, but if you do this, it will become apparent what to work on. So after all of that, how do we think about building our eval harness? I'm going to tell you about one approach using LLM as a judge, okay? Now, here we have, in this system that I've just been describing of a RAG system over workshop transcripts, I've built an LLM as a judge. And once again, I just want to demystify, essentially, it's a prompt with maybe a few shot examples. Like you'll say, these are good responses, these are bad responses, and these are reasons, okay? So you can see here, what I've said is, use GPT-4, this is the doc string to evaluate RAG response, and then I build the prompt, you are evaluating the output of a RAG system for workshop transcripts, paste the question, give some good examples, give some bad examples, then give it some evaluation criteria. It's acceptable if it directly answers the question with specific details. It is accurately correct based on the workshop content, and so on, okay? I do want to make clear, though, that when we just did pass and fail, the astute viewer here will say, oh, you weren't doing pass and fail based on the actual sources that it was drawing on from the transcripts. And I'll say that's absolutely right. So you do, in the next pass, you will want to make sure it's grounded in the examples. But this is a first pass just to see what's working and what isn't. So this is the LLM as a judge, and you pass inputs and outputs through that, essentially, okay? And so that's what I did. And once again, I spun up a custom JSON viewer to do that. And we can see there's a question here. How can I approach prompt engineering according to workshop 1? Now, this is the OpenAI system's response, and this is the Gemini system's response, okay? Now, what you'll see here is it actually says OpenAI evaluation and Gemini evaluation. It makes it look like it's a different judge. That was a problem with the way I vibe code this, and I messed it up, but I've left it in here just to demonstrate that we can still, you need to be very mindful and careful when software composing and vibe coding. So all that's to say is here we have an OpenAI judge and an AI system, RAG system with OpenAI model, and then one with Gemini model, okay? And we can see the judge failed this one and gave this one a pass, okay, with reasons. Similarly, this should not say inconsistent judgment. It should be, do the models both pass or both fail, essentially. Okay, so I'm able to now introspect into what the judge is doing, okay? And similarly here, what is the difference between LLM fine-tuning and prompt engineering? So we can see here the system said, according to the workshop, fine-tuning, prompt engineering, both important aspects. Fine-tuning involves adjusting the pre-trained language model to make it more suitable. On the other hand, prompt engineering focuses on designing, optimizing prompts. Yeah, I give that a pass. And the judge says, yeah, for the same reason. Now, look at the Gemini response. Sorry, an error occurred with Gemini. You exceeded your current quota. So this is massive fail. And thank goodness the judge gave it a fail as well. The judge's response says the response does not address the question at all. Instead, it provides an error related to which is irrelevant. So I'm fine with that response, to be honest. I would prefer a judge that would say, hey, dude, your system errored out with rate limit, so you need to fix that. It doesn't quite catch that, but it gave it a fail, so I'm chill with that. What I do want to say, though, is the next step is to start aligning the LLM judge with your own evaluations. And you don't need another judge to do this. What you want to do is start changing your LLM as a judge prompt. So you could add something like this. If there's an error, inform me there's actually an error. These types of things, right? But what you can do is you can plot agreement rates between your LLM as a judge and your human evaluation as you continue. And after several iterations, a lot of the time, if you've had a bit of practice, most of us become quite good at aligning these quite quickly, which is super cool. So now I want to talk a bit about observability and instrumentation in dev and prod, okay? So remember, the core loop is evaluating cost, accuracy, latency, and business metrics. They somehow disappeared. They often do. So don't let them do that. Comparing them when you switch out things in the AI system. This is the type of eval harness you want to build and iterate on. You want to look at LLM as a judge to help. You want to look at structured outputs, regular expressions, God forbid, string and fuzzy matching, okay? Now, how do you do this? I've shown you can do it with basic logging initially, where you log a system prompt on the user side, user prompt, tool calls, function calls, if any. You got your front-end UI. Then on your LLM API, you're logging LLM response, outputs, token usage, errors, latency, cost tracking. Now, I honestly suggest everyone start doing this using their own tools initially, hand rolling things using spreadsheets. There are lots of wonderful tools out there. Comet has an amazing ecosystem of tools for this type of stuff as well, which I presume is one of the reasons you're here, besides all the wonderful talks. I'm not talking about this one, but all the other wonderful talks. I'm here, so definitely check out Comet and Opic as well if you haven't yet. Do yourself a favor. But you want to be able to log your LLM app like a system, right? Like a software system. And once you've logged everything, then you can start thinking about monitoring and observability, which of course is what Opic and the Comet ecosystem excels at, where you track and optimize cost. You can inspect accuracy and errors. You can visualize latency trends and explore user and business metrics and how you're meeting them. Okay? So, in closing, what we've built and talked about is a minimum viable evaluation framework. So I've built a simple RAG app and talked you through it. We've defined personas and realistic scenarios to simulate user needs. We've generated synthetic questions to simulate user needs. We've used two LLMs, GPT-4, Gemini, to generate responses, labeled outputs manually to define correctness and failure modes, built an eval harness using those labels, compared outputs from multiple models, and used failure analysis. Very important to drive iteration improvement. Now you can go away and build an MVE, my people. You can build a fast, transparent loop for testing and improving LLM apps, even before you have real users. And of course, when you do. As I said, I just came out of working on this type of thing with around 100 people in a course that I teach. There's another cohort actually coming up in July. And this is going to be a super fun one. We do a lot of stuff on Discord, a lot of hands-on workshops and weekly building sessions, a lot of fun guest talks with people from the ecosystem who you know. And we've got a bit of sponsorship so far. We actually had a lot more. We've currently got sponsorship from Modal and Google, so you get a bunch of compute credits, and we'll have a lot more announcements there. And because I love what everyone is up to at Comet, we'd love to offer anyone here $200 off with the code COMETFRIENDS. Use a QR code or check that out. And I'm really excited to ask questions. And thank you all for attending. And thanks once again to Comet, not only for an invitation. As you probably gauge, I love talking about this with people and building with people. But thank you, Comet, for such an incredible conference. All right. Peace.